So in the last part of this week, we're moving on to Chapter 8, which is going to be our quadratic equation section. We're just going to get into that first section in this video. We're going to review the zero factor property. We're going to review the square root property. We're going to solve some quadratic equations that are in this format by extending our square root. We're going to work on completing the square, which there is a handout for. And we're also going to work on quadratic equations with solutions that are not real numbers. So we learned about those imaginary numbers, and now we're actually going to be applying those imaginary numbers. So a quadratic expression is something with a squared exponent and the leading term. Typically, we have three terms, and we need to move them into standard form. So when I talk about standard form, I want to have A, B, and C on the left-hand side, and I want to have 0 on the right-hand side. It is called a second-degree equation. We don't hear that very often, but because the highest exponent is a 2, it is considered a second-degree equation. So let's review the zero factor property. If A times B is 0, then either A or B has to be 0. That seems kind of redundant, right? We already know that. Something times 0 is always going to be 0. This is how this plays out, though. I would want to move the 1 over by adding it to both sides so that I get my quadratic in standard form. Then I'm going to factor this. So if this has to equal 0, then one of these parentheses must equal 0. So that is why you break it out and set it equal to 0. So you may not have realized you're already doing the zero factor property, but you're not actively calling it that. So I solve each one for 0, and I get 1/2, and 1 is the solution set. So there's nothing new procedure-wise here. We're just calling it a formal name. So what we have been doing is a lot of times we've just had the positive answer for a square root. Well, now we're calling something extra out. And we're saying it could be a positive or a negative, because negative 2 times negative 2 is positive 4, but so is 2 times 2. So when I have m squared equals 64, I can take the square root of both sides, and I get m is 8, but I also get negative 8. So we're extending what we already know with that solution. In part B, if I want to solve for x squared, I'm going to add 54 to both sides. I'm going to divide both sides by 3 to get that x squared alone. And then to get rid of the x squared, I will take the square root of both sides. But my answer will be positive and negative. And then you want to say, wait a minute, can I reduce that square root? Well, yeah, you can. I can do square root of 9 times square root of 2, but they still remain a positive answer and a negative answer. So that's what this section is really about, is that you're going to get a positive and a negative. So let's look at an application problem. Here we have a marksman who can hold a silver dollar at the forehead level, drop it, draw his gun, and shoot the coin as it passes his waist. So he's very, very fast at this. If the coin falls about 4 feet, use the formula distance equals 16 times t squared to find the time that elapses between the dropping of the coin and the shot. Well, I know my distance is 4. That's what he told me. So if I'm solving for time, I'm plugging in 4 for my distance. I'm dividing both sides by 16. Then I'm going to take the square root. Well, mathematically, in our perfect math world, we know we get a positive and a negative answer. But can time be negative? Think about that for a minute. Can you have negative time? No, we can't. So we say that it's only going to be the positive 1/2. So in our perfect math world, we get a positive 1/2 and a negative 1/2. But in the context of the problem, I can't have negative time. So be on the lookout for that in the lab. When we're dealing with application problems and square roots, you cannot have a negative time value. So here we have a new type of quadratic that we're solving. I don't want to FOIL it out, guys. Some of you may love to FOIL things out in factor. It is not my thing. So when I see this and I've got something squared equals a value on the other side, I'm just going to take the square root of both sides. That's what I'm going to do. I'm going to take the square root of both sides, and because you have that square root property, you're going to get a positive square root and a negative square root. Then you're going to solve it. Now, what would happen if you FOILed out the left? You would get the same answer. It would just take you more steps. So what you have to remember is, yes, I'm taking the square root of both sides, but I branch it out into two equations, one accounting for the positive, one accounting for the negative, and then I solve for x. Then I'm going to check, because remember, guys, when we talked about when we do that square root, we always have to check. They both work out. So remember when I said there's no hard and fast rule about one answer not being correct? This is a perfect example. So anytime we're doing that square rooting of both sides, we want to also check our answer, just like when we squared both sides. Now again, you could FOIL this out on the left if you choose to. I definitely don't want to do that. So I take the square root of both sides. And I get a positive square root of 2 and a negative square root of 2. So I'm going to bring that 1 over, and then I'm going to divide by 3, and that's okay. We can have that as final answer. It's not a problem. So I have two final answers, and you're going to say, well, wait a minute, how on earth do I check this? Well, what you can do is use that Web 2.0 calculator and do 3 times this whole quantity plus 1 squared equals, and then see if it equals 2. You can check that with your Web 2.0 calculator. So this is exactly what you would type in with the brackets and the parentheses into the Web 2.0 calculator. You would not hit the equal sign. You would just be typing in what's on the left. And it would tell you it equals 2. So this is simplifying by hand, but you could take this first step and go ahead and type it in. All right, completing the square has a series of definite steps that have to happen. Check out the handout that I posted in the class area, and that's going to really help you with this week. So for completing the square, the first thing you want to do is move your constant term over to the right. So I add 10 to both sides. The next thing you're going to do is look at the number in front of x. To complete the square, you're going to take the number in front of x, divide it by 2, and then square it. So negative 2 divided by 2 is negative 1. I'm going to square that, and that is what I add to both sides. Okay? So I moved the 10 over, I did this arithmetic in the margin of my paper, and that's what I add to both sides. Now, it should always factor to what you got for this step. So negative 2 divided by 2 is negative 1, so it's minus 1 squared. It's always going to factor from this step right here. So right here is where you're getting this number from. I square root both sides, I solve, and then I would check my answer by, again, plugging that into my Web 2.0 calculator. Here is another case. If there is not a number in front of x squared, it goes simple, right? You just move the c over, divide by 2, square it, add it to both sides, and you're done. If there is a number in front of the x squared, there is an extra step we have to account for. We have to get that a gone. So let's see how that works. Here, I have no a in front of my x squared, so I just move the 1 over. I take 3, I divide it by 2, I square it. I add that to both sides. It will always factor to what you have before you squared it. Then I take the square root of both sides. I bring the 3/2 over, and I get this complex value. I check my answers, and that's my final answer. So it's not too bad when a is 1. When a is not 1, you divide every term by a. So I'm going to divide everybody by 3. That's not pretty, right? I'm going to move my constant over. I'm going to take that middle value, divide it by 2, and square it. I'm going to add that to both sides. It's always going to factor to the value you got right before you squared it. Then I take the square root of both sides. I'm going to get that denominator rationalized. Or here they took it and they didn't rationalize the denominator first. That's fine. Then I'm going to bring that 1 over by subtracting 1 from both sides. Why is the negative 1 in front of the root? Because that's what our convention says to do. I need to get a common denominator, so I'm going to multiply negative 1 by 3 over 3. so I can get it into the same fraction. If you're entering this step in the lab, it's going to tell you, hey, there's a mistake in simplification. You've got to multiply by 3 over 3 so you can combine that fraction. Same thing over here. I can subtract the 1 over, rationalize my denominator. So I get square root of 3 times square root of 3. 5 times 3 is 15. Get a common denominator, and there's my answer. I can check those using my Web 2.0 calculator. Now, there are times, because you're taking the square root of both sides, where you may have a negative number, and that's okay. You're going to work with I because we now are equipped to work with negative numbers. So when I square root both sides, I have the negative under there. I'm going to pull that I out just like I did in the last unit, and that's my answer, and that's okay. Same thing here. I'm going to square root both sides, and I can take that I and use the I. And I'm just going to solve it by subtracting 5 from both sides, and oh look, I still have an I in my answer. That's okay. Here, I can complete the square, divide everybody by 5, move the 12 over, take that middle term, negative 3, divide it by 2, square it. See, look at my margin. Add that to both sides. It always factors to what you had before you squared it. Take the square root of both sides. Up, it's got a negative number. That's fine. I'm just going to put an I in front of it. I'm going to rationalize it. I'm going to add 3/2 over. It's a lot of math, guys. This is a lot of the previous knowledge, so you can definitely pause this video, work it out with me. You could multiply by the square root of 20 over the square root of 20 right here. That's fine. It just means that it's going to reduce at the top, so there's an extra step, okay? They chose 5 because 20 times 5 is 100, which is a perfect square. You could just do 20. You're going to get the same place. So take the I out, then worry about rationalizing, then worry about adding 3/2 to both sides. And that's the end. So I really strongly recommend you go back in this video and rewatch all those steps happening and just pause, work out your step, then listen to what I say. Then pause, work out your step, listen to what I say, because it's putting everything together from elementary algebra all through what you've learned in chapter 7 into this new section.